Hi guys, it's Miss Carr. I'm here in the classroom all by myself again. Hopefully you guys will be back here soon and we will be able to stay in school longer than just a week like we did last time. But continue to try to stay safe so that we can be back in school. Anyways, we're going to be talking about completing ions today, or creating ions today. And so if you have your notebook and a pencil out, that will be really great so you can keep these notes and use them to study and to do your work. While you're pulling that out, I'm just going to remind you kind of about the things we talked about last time in the other video. And we were talking about valence electrons. We were talking about drawing and stuff like that, drawing them on our elements. And so if you guys remember, we kind of saw a trend with our periodic table. And we saw that ones over here on this side of the periodic table, that they usually had just 1 or 2 valence electrons. And then when we got over here, we could see that it went to 4, 5, 6, 7, 8. So depending on what group we're in is how many valence electrons there were. So that's going to be really important when we're starting to talk about this stuff, okay? So that you guys don't have to redraw it every time. You can just look at your periodic table and say, okay, I know that this element is in column 5. That means it has 5 valence electrons. So that's going to be a really important thing for you to keep in your mind. And like I said, you can write on your periodic table. You know, if you write a 5 up at the top, you can know that everything in that column is going to have 5 valence electrons. So you don't have to memorize it, you can just write it down and have it with you. All right, hopefully you have a notebook now and a piece of paper. So let's get started. So I'd label your notes, creating ions. And then for today, we're talking about ions. And if you remember back to the first unit, ions are dealing with electrons. So we're going to be talking about electrons here. We're going to either be adding electrons or taking electrons away to create ions. And so you guys will soon be able to create your own ions and know which ions exist in the world and which ones don't really exist. Which ones will have a positive charge or negative charge, things like that. All right, if I ever go too fast, remember this is a video, so you can just pause it, write down the notes, and then keep moving on, okay? But I'm going to show you the next whiteboard. So our next one is kind of a reminder about our different shells. So one thing is that elements are happy when they are full. So that's going to be something we're going to talk about a lot. Elements want to be full. They want to have those outer shells, you know, when we drew the shells last assignment, they want those to be full. And so if you remember from the last assignment, in the first shell, 2 electrons mean it's full. And in the 2nd through 7th shell, 8 electrons mean it's full. So elements are going to try to create full shells by either getting to 2 electrons if they're dealing with the first shell, or to 8 electrons if they're dealing with the 2nd to 7th shell. And there's 2 different ways they can do it. So the first way that they can do it is they can add electrons. So they're going to add electrons to create a full shell. The second thing they can do is they can take away electrons. So, sorry, the Y erased. So that one says take away, take electrons away. So they can take electrons away, and as they do that, they can delete that shell and they can have a full second shell. So I'll show you. If this is not making sense, just copy it down because you can refer back to it. And when we do the examples, you'll see a little bit better, okay? So pause if you're not done, but if not, we're going to move on to the next whiteboard. All right, so now we're going to be looking at some examples, okay? So the first example we're going to look at is fluorine. It's F. So if you can find it on your periodic table, it's up in the left corner. You can see F. You can see that it's number 9 if you're having trouble finding it. You can see that it's in column 7A. So because it's in 7A, it tells us that it has 7 valence electrons. So if you count, you can see I have the 2 in the middle, and then I have 1, 2, 3, 4, 5, 6, 7. So it has 7 valence electrons. So for fluorine, if we want to make it full, if we want to make it to have 8 electrons, or 2 if we're dealing with the first ring, but we're going to deal with the second ring, if we want this to be full, do you think we're going to take electrons away, or do you think we're going to add them? All right, hopefully you kind of thought to yourself, we have 7 electrons and we want 8, so we're just going to add 1. So let me add 1 right now to fluorine. Okay. So the electron that I'm going to add is going to be green. Okay, this is the electron I'm adding to fluorine. Remember, try to copy this down or pause at the end and draw it, and draw your electron maybe in a different color so you can remember that's the one you added. So we added now an extra electron to fluorine. So fluorine, it normally has protons, 9 protons, right? And it normally has 9 electrons, right? If we counted up our red ones, we would see that it equals 9. But now we added an extra one. So now we're going to have 10 electrons. And just like before, we can see our proton number is 9, our electron number is 10. We have more negatives, more 10, this 10 is bigger than the 9, more negatives than our positives. And because of that, this is going to have a charge on it. So think to yourself right now, if I have more negatives than positive, what's my charge going to be? Hopefully you're able to say this is going to have a negative charge. And this one is just going to have a -1 charge because we just have one extra electron. If we had 2 extra electrons, it would be a -2. If we had 3, it'd be -3, things like that. But this one's just going to be -1, all right? So on your assignment, it's going to ask you for things. It'll be like, if we have fluorine, what's its most common ion? And you'd have to think, for fluorine, we normally just add 1 electron. So it's normally a -1 charge. Fluorine's not really going to have a -2. It's not going to have a positive charge. It's normally going to have a -1 charge, okay? Also, things like this, we can use our periodic table again as a trend. So since fluorine, it's in the 7A column, everything in that column is going to have 7 valence electrons. So all of those things, we're just going to add 1 electron to create 8 on the outer shell. And so everything in 7A is always going to have a -1 charge. So you know that any of those ions are always going to be a -1. That's another trend that you can know so you can finish your assignments really fast. All right, let's look at the second one. It's magnesium, Mg. So if you find it on your periodic table, it's on this right side. It's number 12. And so it's going to have 12 electrons. So you can count out the electrons if you want, but there's 12 electrons here. And so for magnesium, it has 2 valence electrons, right? It's in our 2A column. So since it has 2 valence electrons, we have to think, what are we going to do? Are we going to add electrons to get to 8, or are we going to take electrons away? So if we were to add electrons, like we did with fluorine, we would have to add 6 electrons, and that's kind of a lot of electrons to add. But for magnesium, if you think, if we just take these 2 electrons away, now this whole shell is going to go away. And if the whole shell goes away, then we're left with now a full shell of magnesium. So that's what's going to happen with magnesium. Magnesium, we're going to take 2 electrons away. So now let's do our proton and our electron number. So magnesium is always going to have 12 protons. That's not going to change. Remember that from Unit 1. It used to have 12 electrons, but we took 2 away on the outside. So now, if you count up, you can see that we have 10 electrons now because we took 2 electrons away to make an ion. So now we have to think to ourselves, what is the charge of magnesium? So magnesium, we took 2 electrons away. We removed 2 negative charges. Since we removed negative charges, now our proton number is bigger than our electron number. So this is going to have a positive charge. Now magnesium, remember, we took 2 away. So if we took 2 away, it's going to have a positive 2. So again, just like fluorine with magnesium, it's on the periodic table in column 2A, right over here. Ooh, there, you guys can see. So anything in that column with magnesium is going to have a positive 2 charge if it creates an ion. So it's beryllium, calcium, strontium, all of those in that column are going to have a positive 2 charge when they form an ion. So that's another trend that you can keep in mind so that your homework and things like that go faster. Okay. So we're going to look at a couple exceptions, and then we're going to look at some rules, and then we're going to be done. So we're almost done, so stay with me. So here are some exceptions. Number 1 is carbon. If you look at carbon on your periodic table, you'll see it's in column 4A, so it's going to have 4 valence electrons. So if we were to create an ion for carbon, we'd have to either add electrons, or we'd either have to take electrons away. If we were to add electrons to make it full, we'd have to add 4 electrons. If we were to take away electrons to make it full, we'd have to take away 4 electrons. And that's a lot of electrons. So carbon normally doesn't form any ions. So again, on our periodic table, if we look at our carbon row, anything that's in this 4 row usually isn't going to create an ion. Okay, there are some exceptions where they will, but for this class, they're not going to create ions. Our next one is neon. And so neon is a noble gas. And if you notice neon, it already has 8 electrons in its outer shell. It's already full and happy. It's not going to create ions. It's not going to borrow electrons or take away electrons, anything like that. It's going to just stay full and happy, and it's not going to create ions. So anything that has 4 valence electrons or 8 valence electrons is not going to create ions. Okay, I would write that in your notes. I'll write it on the board and show you, okay? 4 valence electrons. All right, here's your note that I would make in your notes. If we have 4 valence electrons or if we have 8 valence electrons, it's not going to make an ion. Okay, so pause the video, write it down, make sure you have it copied. Okay, we're going to talk about our last thing. These are just some rules that you can kind of memorize and it will be easier for you. Okay, so first one, if it has 3 or less electrons, we're going to take them away. We're going to take electrons away. So if on our outer shell, like magnesium, it just had 2 electrons. Or if we did another element, it might just have 1 electron. Or another element might just have 3 electrons. So whatever has 1, 2, or 3 electrons on the outer shell, we're going to take electrons away. And when we do that, it's going to make it positive. Okay, that's your first rule. So copy it down and let me know if you don't understand that, and we can explain it again, okay? Your second rule is that if it has 5 or more electrons, we are going to add electrons. So if it has 5 or 6 or 7 valence electrons, we're going to add electrons to make it be full and have 8. Because you see with 3, it's easier to take away electrons to get it to go to full, and with 5, it's easier to add electrons to make it be full. Okay, because we don't want to be adding or taking away too many electrons. So this one makes it positive. This one, when we add electrons, remember electrons are negative, so if we add them, it makes it negative. Okay, these are really important rules, so make sure to pause the video and get them down. Just another thing for the periodic table, let me show you really fast. So these ones, and this one in column 3, remember this is going to have 1, 2, and 3 valence electrons. And if it has 3, we always are going to take away electrons, and it's always going to be positive. So these ones in these columns are always going to make positive ions. Okay. Then, if we look at these columns, 5, 6, and 7, they are always going to add electrons and become negative. So these are always going to have a -1, -2, or -1, -2, and -3 charge, depending on how many electrons we're adding. All right, hopefully this helps you guys finish your work. Like I said, these assignments are supposed to be pretty quick because you can use the periodic table as a model as you are doing your work. So if it's not quick for you, you need to let me know and I can re-explain things and show you what the trends are so that you can get your work done fast. All right, let me know if you have any questions. I know this was a little bit of a long one, so thanks for staying with it. Good luck finishing up your assignments this week. And please reach out if you have any questions or need any help with anything. Okay, I'm here for you guys. Have a good weekend.